Let's see how we can use stacks to develop some useful applications. I got 3 examples for you. And for the first one, it's simply to reverse an array. That one is rather straightforward application of the level last in first out property for the stack. So for that one, I'm going to give you the solution and also go over some test cases with you directly. But for the next 2, I will give you maybe the opportunity to really pause the video and think about your solution. Let me just show you how you can find out the source code. I got most of them available to you, but some of them will be left as exercise for you, which I think is quite important for you to complete it on your own, and reach out to me if you got any problem. And if you go under the example generic stacks projects, under the model package, go to the stack utilities class over here. Right? You can see I got the source code for the first and also second exercise for you. And for the third one, which is about how to implement a postfix calculator, I'll leave that implementation to you. I think it will be very nice programming exercise for you as well. I'll leave that to you. And if you want to see the JUnit test cases, if you want to use the breakpoint and debugger, you can actually go to test stack applications over here. Right? Again, I got the test cases for the first 2. Once you develop the solution for exercise number 3 for the postfix calculator, you can also write your own test cases here. Let's now go back. Okay, and for the first one, let me just go directly to talking about the solution. So this is the solution over here, which is called reverse, and we're taking some generic type array, meaning that it can be array of string, can be an array of integer, or etc. And this is some more advanced example about using generics. We are defining the generic parameter not just at the class level as we said earlier, but we can also do it at the method level. So this is something called generic method. Right? Let me just talk about it. This will be some very useful syntax and also concept you can actually pick up for your further developments. So this is a generic parameter at the method level as opposed to at the class level. And whenever you have a generic parameter, you should really think about when would I instantiate it to be a concrete type. For example, when would I instantiate the E over here to be a string, to be an integer, to be a person, or etc. Right? As soon as this parameter E is instantiated to some known class, in that case, every occurrence of E will be instantiated accordingly. Right? Let me say it again. So you can think about this is the declaration of the generic parameter. And every other occurrence of E in the scope of this particular method, for example, E over here, and that's it. And also E over here as well. You know what? I think, yeah, that's good. So these are the 3 instances of the parameter E, which will depend on exactly what class you're going to instantiate this E into. Right? So this will be something very useful for you to pick up. Okay? For example, if I try to invoke this method over here, let me use example number 1. If I say reverse, and then I pass an array. So this is not exactly valid Java syntax, because you cannot just write out the array directly as an argument, but just conceptually. So depending on the type of this the array, the reverse method generic parameter will be instantiated accordingly, right? So let me just write this out directly. But to really be valid Java syntax, you must create this as an array separately. Okay, that's something you can try on the Eclipse. So I might just say maybe let's say Alan, and also let me just put 2 elements in the array. Right? You can see this one over here is really an array of string, right? So the type over here is really a string array. So what this will do is it's actually going to instantiate the E over here just by string. Accordingly, it's going to instantiate every occurrence of E over here also by string. That's what the compiler can figure out for you. So once you have done that, specifically, that means you're also going to instantiate this local variable stack as of type string. Meaning that when you actually want to reverse an array of type string, where every element is a string, accordingly, it's going to create certain a stack where every element or every item in the stack will just be a string, right? It's actually very important for you to actually see that, right? So let me just try to use this particular example here. So this will be string. So that means we're going to instantiate this by string. Accordingly, this will be instantiated by string. And also here will be instantiated by string as well, right? So that's one example. What about another one? What if we say reverse? Over here, we're calling the same method, but I give you another array. Let's say 23 and also 46, right? In this case, every element in the array is actually integer. So that means it's going to instantiate this particular generic parameter as an integer instead, right? So what's going to happen is, I'll just say I for short, right? So let me use pink. So integer over here, and accordingly, this will be instantiated as integer, and locally, we're going to create a stack of integer as opposed to a stack of strings earlier. And also, this will be integer as well, right? You can see the principle here of instantiating the generic parameter is really the same. It's only a matter of whether you instantiate it at the class level or at the method level, right? I would say really learn about this generic method. It's very useful, okay? Okay, that's about the syntactic, the new syntax I would like you to learn. And let's now talk about the algorithm itself. It's very straightforward. Basically, if you want to reverse the input array A, what you got to do is you're simply just going to go over the array element by element from left to right and simply push all the elements into the stack in a particular order. And then you're going to pop them off in the reverse order. Remember the last in, first out property that we spoke about before, right? Presumably you remember that. And also, once you actually got pop them up in the reverse order, save them into the input array. That's how you reverse it. Let's now take a look at the test cases over here. And if you look at the test cases, you'll see exactly how this has been set up. So you can see here we got the inputs over here, Alan, Mark, and Tom, and then we are passing the names over here as the input, and then after calling this method over here, the names will be reversed with the expected reverse of names, which will be Tom, Mark, and Alan. All right, and let me, before I trace the algorithm together with you conceptually, I want to show you another thing. Just notice that the valuable points I'm really trying to demonstrate over here. This is just about a test case for an array of string, right? Let me just say this. This is the first example I'm giving to you. So this is actually handling an array of strings using a stack of strings. As you can see here, let me see this. So you can see this is an array of string over here, and then when I'm passing the names as the input parameter over here, everything is going to be instantiated accordingly to a string, as I illustrated before. On the other hand, if you try to look at the second one, right? So you can see here, I got another input. So that's an array of integer. So you can see that's an array of integers over here. And then I'm passing that array of integer as the arguments over here. And what about the expected array? In that case, it will be the reverse order, and it's going to be passed over here, right? To really do the assertion checking to make sure they are actually the same. All right, and for this one here, you can see we are really calling the same method over here. The same reverse method is actually being called over here, right? The same block of code. But because the method itself is generic, so that means depending on the type of the input array, you will be able to instantiate the local stack element type accordingly. That's really the valuable lesson we are learning over here. Right, let me also make a note quickly, and then we'll trace just the maybe stack the string version quickly. And for this one, it's very similar. So the way the algorithm work about exploiting the level property is really the same. It's just that in the first block, it's the array of strings that we are manipulating, and the second one is really the stack of integers that we're manipulating. So this will be handling an array of, I'll say ints for integers, using a stack of integer, right? Let me just highlight what I really meant to express over here. So you can see array of strings using a stack of strings versus an array of integers and a stack of ints, right? All right, let's now trace the code very quickly together, okay? The way to trace it is by just conceptually, right? Very quickly. Let's say we got Alan, Mark, and Tom, right? And when we execute the very first loop, what we will do is we're just going to go over the array A from left to right and keep pushing, right? So let's say this is the array A, right? So that's the input. And we simply got Alan, Mark, and Tom. Okay, so this is the input array. So we got Alan. I just wouldn't put it into the crow just to save my writing. Mark. And also Tom over here. So this is the input stack called buffer over here. So this is our buffer stack. And we're going to push in this way. Alan followed by Mark followed by Tom, right? You can see from 0 all the way to the last index. So we're going to get Alan being first pushed, and then Mark, and then Tom, right? So that's our intermediate stack buffer. And when we execute the second loop over here, we're actually going to, so I think this part over here is just to say how many pops do we really need in order to get the reversal of the original array. And that's exactly a.length number of times. And then we're going to reassign every index of I from left to right over here to be whatever we pop off from the stack. And of course, it's going to be in the reverse order. So if you think about it, so the first iteration here is going to pop off Tom. That means we're going to set index 0 over here to be Tom. And then for the second iteration, we're going to pop off Mark, right? Of course, after the first pop off, we actually got Tom removed. And then we're going to, don't forget, the pop itself actually will return the old top as we illustrated before. And when we pop off Mark over here, that will be index 1. That will still be Mark, right? So that one actually is unchanged, but that's okay. And the final one, we're going to pop off Alan, index 2, so that'll be Alan. Right? That's basically how the algorithm works. And if you go to trace the second block for an array of integer, it's going to work algorithmically the same way, even though it's a different types. It's a different type of array. All right, so that's the conceptual sketch, conceptual tracing for the reversal. And I will encourage you to also try to actually go to the test method over here and try to trace line by line, at least for this block, or either this block or maybe this block over here, to see exactly things work, and step into the reverse method over here and see how things work. That'll be some recommended exercise for you. All right, let's now move on to the second application.